Hello, welcome back to the continuing lecture in investment analysis. Um, this is Dr. Jeff Hong. Now, continuing with our discussion about the immunization, right? Here's the, we need to take a look at this graph, which is, capturing, basically where duration and the maturity are, tangent to each other. Now, we understand that duration matching the balances the difference between the future value of the coupons with the bond price, and the future value of coupons is basically the result of taking advantage of the reinvestment rate risk, and bond price is basically price risk, and they are balanced out, right, through duration match. Now, so when interest rate goes down, coupons grow less, but it's offset by higher bond price. But when interest rate goes up, bond price goes down, but higher future value of the coupons more than make up for that, loss, since the coupons are reinvested at higher interest rate. Okay, so that's basically what we already know. But even if interest rate, this Y is the same thing as R here, because it's the basically the market rate and this discount rate. If interest rate goes up at a particular point in time, called T star, and this is basically what we can't predict, because this is a sudden and unexpected fluctuation in interest rate. So even if interest rate goes up, initial loss due to price risk is offset by reinvested return increase in coupons, right, and vice versa, and the same at duration, right, and in our example that is year 5, where and solid curve represents the change in the when there is no change in interest rate, right? So solid curve is basically capturing the change in accumulated value of invested funds. In other words, the future value of invested funds over time, right? And it is a curve, definitely, because it's exponential, right? We're dealing with exponential functions, right? Or power function, right? So, future value is always, something raised to power, right? But if interest rate and that's the solid curve, and the dashed curve represents the scenario under change in interest rate, and especially interest rate going up, because the change is positive, right? Because the change is positive, that means positive change, right? God, that's so hard. Positive change, right? Ah, positive change. Okay, I'll just I'll just settle for that. Um, if it is so, eh, when there is no change in interest rate, I mean, when coupon rate is this is actually not the coupon rate, something I should have so actually, what should I have? I'm gonna have to change that to so when interest rate is 8%, right? Then the duration is 5 years. But when interest rate is 7%, then the duration is 5.02 years, right? Slightly long. When interest rate is 9%, duration will be 4.97 years, right? Uh, so this is, uh, obviously, duration, and that was uh, rule number 4. I mean, if I remember correctly, right? Um, the as over time, as interest rate changes, right? Uh, or yield to maturity changes, right? Uh, Duration doesn't stay the same. Of course, these are variables. When one variable changes, the other variable will have to also change as well. Now, and let's take a look at the table 11.5. And table 11.5 is actually um, looking at the same example now from present value perspectives, right? In other words, we we took a look at it from future value perspective, right? Future value of the fund perspective, and what for incremental change in interest rate, for incremental change in uh, interest rate, right? Uh, the future value of our assets still, prevail over the future value of our obligations. So it's immunized. Our, obligation is immunized, um, and we looked at it from the, duration perspective, right? And we also look at it from the present value perspective, right? When interest rate is 8%, right? Which means, yeah, when Y is 8%, yield is 8%, right? Of course, it's all, even in present value perspective, it's all, immunized because um, when interest rate is 8%, no change, right? Assets and liabilities exactly balance out, right? they exactly balance out. Interest rate goes down to 7%, then you would have greater present value, right? That is present value because it cannot be future value, right? Our present value of our assets, is 10,476 and slightly greater than the present value of our obligation, right? So, our portfolio is immunized, right? When interest rate goes up, in terms of present value, right? Still, our bond portfolio is greater than our assets are greater than our obligations, right? Our claim, right? In other words, still, we are immunized, right? So from future value perspective, from duration perspective, from the present value perspective, our portfolio is immunized, right? Or rather, our obligation is immunized. But the immunization is not fact, as there exists surplus in the bond fund. I mean, surplus is nothing to complain. Surplus is nothing to complain about. Why? Because this small breadcrumbs, at least if we have surplus breadcrumbs, that goes to the portfolio manager, and from portfolio manager's point of view, nothing to complain, right? But I mean, this is not perfect, matching. I mean, mathematically, that's what it means. It's not perfect, right? And also, it works only for small change in, only marginal or incremental change in interest rate, as I said. It's going to be very difficult when interest rate change is, significant and huge, like 4 or 5% change over 1 year. This is, it's not going to work that easily. And this is because of, this is due to duration rule number 4. And, I also mentioned this, in the previous graph, as the yield changes, duration changes as well. I mean, a change in interest rate causes change in, or leads to change in duration, right? Because it's like elasticity. And if you think about it, actually, duration is like the slope of a curve. Let me go back to I don't know what that graph was, but yeah. See, this is the graph of sensitivity, right? Between change in interest rate and change in interest rate and change in bond price, right? Remember this, and you see, this curve is like a demand curve, isn't it right? Because this is showing you the sensitivity between the change in interest rate and change in bond price. So it's like, exactly like demand curve, in demand curve, right? usually quantity is on the horizontal axis and price is on the vertical axis, but um, you can flip it as well, and you still get the same downsloping curve, right? You still get the downsloping curve, and we uh, even if you put usually dependent variable is put on the y-axis and independent variable is put on the x-axis. So uh, when uh, between price and quantity demanded, right? Um, it's a function of price, right? Quantity demanded is a function of price. Also, quantity supplied is a function of price. And you remember in microeconomics, supply curve is upsloping, right? Whereas demand curve is downsloping, and an approximation of demand curve is always approximation of demand curve is a downsloping straight line. Actually, it's an approximation. You all know that the actual demand curve it's literally curved. That's why they call it curve, right? That's why they call it curve. It's exponential. Uh, uh, it's not a straight line, right? Straight line is only an approximation. Just like that, duration is a straight line because it's a slope. Duration is a slope. Slope of a curve is a straight line, right? So um, uh, if you think about it, actually, duration is uh, just like the elasticity. Elasticity is a straight line, right? Expressed as straight line, tangent to the demand curve. But think about it. That's why it's called, point elasticity. Point elasticity, right? Because you are finding elasticity at a particular point. But since it is a curve cannot have just a single slope, right? I mean, the slope here is different from slope here, right? I mean, a curvature has, infinite number of slopes as the curvature, as you move along the curvature, right? So just like that, duration is only an approximation, and because it's the slope of this curve, right? And that's why uh, duration changes as uh, interest rate uh, changes, right? Um, so that means as uh, because duration changes together with the change in interest rate, rebalancing is warranted. Rebalancing is needed. Rebalancing the immunized portfolio is warranted. And rebalancing is adjusting portfolio to realign duration of the claim with the duration of obligation as they change. Okay, that's not a difficult concept to comprehend. So, I went all the way back to explain that concept of a straight line duration. Now, so this graph explains, that concept of rebalancing because now, so think about it. This solid curve is representing the value of coupon bond, right? Value of our assets, right? for our claim, and this is our obligation, right? In other words, single payment obligation, right? So in other words, GIC, right? And when interest rate is 8%, and with a coupon bond, with at 8% coupon, right? Then duration is matched at this point where they are tangent, right? In other words, our obligation has this obligation grows like this, at different interest rate, but at 8%, our value of our obligation matches the future value of our present value of our obligation matches the present value of our coupon bond. But as interest rate changes, right, they diverge, right? So that's why the rebalancing is warranted. So therefore, immunization is not actually a passive strategy. I mean, immunization is supposed to be a passive strategy. Passive strategy means what? You already immunized the. You already immunized your obligation and your asset portfolio, right? So for small change, it will be okay. Small change in interest rate, it will be okay, right? It's supposed to work. It's supposed to work as planned, right? For small change and for small, relatively short time horizon. But then, as time horizon grows, right? Of course, a single obligation, one particular specific obligation, and the asset fund cannot change in time horizon. I mean, it's because time horizon is already fixed, but let's say what I'm saying is, when we are dealing with obligations and asset portfolios, with varying, with different time horizons, right? The longer the time horizon, longer the maturity, right? The chances of immunized portfolio diverging from the in the future, right? In the future value, right? As time goes on, will be significant because interest rate. There's a good chance that the interest rate might fluctuate, right? The longer the horizon. That's why it's called maturity risk as well, right? But anyway, so immunization is supposed to be a passive strategy. Passive meaning passive a portfolio management strategy. Passive meaning you just set it up. You just match the duration and you don't have to do anything. So it's passive, right? But because you have to rebalance it, right, over the longer time horizon, right, you will need to rebalance it, and rebalancing is not a passive thing. It's an active management. Isn't it right? If you rebalance, every couple of years, every 3 years, 4 years, practically you cannot rebalance. You can, but practically it's very cumbersome to rebalance it every year. I mean, unless there is a significant, a discrepancy, a significant change in interest rate, and unless there's a significant discrepancy, between the asset value and the liabilities values, right? Then rebalancing is needed every year. But usually, you don't. The rebalancing isn't that frequent. It's probably every couple of years. Not every year, right? But anyway, the act of rebalancing is already an active management active management behavior. It's not a passive behavior, right? So that's why it's not immunization is not really a passive strategy, right? It's only a passive strategy in the sense that it does not attempt to identify undervalued securities, but over the long term, right? You identify undervalued securities and rebalance, right? So that's there's an active management component, right? Active management. So let's take a look at this example. So as yield changes, so does the duration change. So does the duration. So position is not fully immunized over time. So we have to realign proportions of assets in portfolio as needed. That's called rebalancing. So in example 11.2, constructing an immunized portfolio, right? Obligation is 19,487 in 7 years, right? If the maturity is 7 years, right? That's our time horizon. And the present value of that GIC is 10K, and at 10%, right? So this means present value of GIC and 7 years later, you will have to pay out almost $20,000, right? And then how do you fund it? How do you, in other words, this is your client's fund, and you took the client's fund, and how would you match it? So you funded with 3-year zero coupons and annual coupon perpetuities. Okay. So then that means with $10,000 you buy 3-year coupons and perpetuities, annual coupon perpetuities. Then our question is, what proportion of that 10,000 do you put into a zero coupon, and what proportion into perpetuity? So it's a question of how to weight it, right? Allocation of weight, right? Well, then first of all, to immunize, right? You have to calculate the duration of the liability, and this is a zero coupon, right? Not this one, but our obligation is zero coupon, right? This because as I told you, this is the par value of your maturity value of your zero coupon, and you buy it, you pay 10K, and 7 years later you're going to collect it. So this 10K is exactly the discounted present value of this obligation, which is zero coupon, right? Discount bond, right? So the duration is, for zero coupon, duration is the same thing as the maturity. So, 7 years. single payment, zero coupon. Oh yeah, I have to write every, zero coupon. I think, I don't have to write. I don't have to write the whole thing, right? What? I don't think, there's space anymore. Anyway, so the point is, and then we calculate the duration of the assets, so then, question is, half part of that is, funded with zero zero coupon, 3 year zero coupon. So duration of zero coupon is the same thing. So it's 3 years, right? But the duration of perpetuity, we know the formula for duration of perpetuity is 1 plus y over y, 1.11 years, right? So then 3 years and 11 years, and they have to be, the weighted average of these two have to be equal to 7 years. So let the weight or the fraction in zeros, W, right, equal to W. So let's call it W, standing for weight, right? And then the fraction in perpetuity is 1 minus W. Make sense? So assets duration is, our portfolio's duration is weight times years plus 1 minus weight times 11 years, and we set it equal to 7 years, right? Which is the duration of our liabilities, our GIC. Of our obligation. I'll just call it GIC. It takes time to write. And we solve this equation for W, right? And then, then W comes to half. That means, we put 50% in the zero coupons, 3 year zero coupons, and 50% in perpetuity. And then a future value of this 10K, which is liability, obligation, which is the obligation, is fully funded by, oops, what did I do? It's fully funded by future value of 0, which can be calculated as 5K times 1 plus 1 raised to 3, and future value of perpetuity at year 7, right, which is 5K, right, times this is basically a perpetuity of right, in perpetuity, right. It's the cash flow dividend over R, right? Dividend over R. And you might wonder, this is the present value formula of the perpetuity. True, but it's the present value in year 7. Okay, it's the present value in year 7, right? And because at that point the perpetuity is calculated, value of the perpetuity is calculated at year 7, right? With the future cash flow, right? So this way, it's perfectly immunized. But then, this is not the end of it. I mean, we are rebalancing it. So first we uh, immunized it, and we need to rebalance it as time goes on. And since we are out of time, I'll have to stop the video here. The video ran almost 42 minutes. Um, and then in the next video, we'll talk about rebalancing it. Rebalancing. Okay, so that's it for now, and I'll see you guys in the next video. Stop recording.